So now let's shift gears into a different type of recycling, and that is called composting. Composting is useful for recycling organic waste. Many cities have actually banned yard waste from being sent to the landfills because they are quickly filling up. And so rather than burying this organic material, these yard clippings, for example, cities are encouraging to turn them into useful compost products. Composting is the biological degradation of organic matter under aerobic conditions. So again, we get to thank our microbe friends for breaking down our waste for us in these compost bins. And the organic compost resulting from this process makes a nutrient-rich soil that is amended with nutrients. It's a natural fertilizer, and it can aid in water retention, it slows soil erosion, and improves crop yield. So again, turning that waste into something that is valuable. Reuse is even better than recycling. Even better than recycling or composting is cleaning and reusing materials in their present form. This saves the cost and energy of remaking them into something else. Auto parts, for example, are regularly sold from junkyards. There's this place in Nashville called Pull Apart, where you go to this lot of these abandoned vehicles and you find the part that you need for your car. There's also stained glass windows, brass fittings, fine woodwork, and bricks that can be salvaged from old houses that have to be teared down or completely renovated, and they can be reused in new construction projects. And then finally, some communities sort and reuse a variety of materials that are received from their dumps. If it was dumped and it's perceived to have value, as long as somebody has the time and resources to repurpose that into something else for a new project, then that is the way to go. Is garbage a resource or is it a liability? Municipal solid waste includes all of our mixed refuse. So it's hard to extract and reuse because they're all usually mixed together, although there are new sorting and recycling systems that can separate that mixed waste. Materials, importantly, we need to remember, can never be destroyed or created. They're just transformed in one shape of another. And so it's up to us to figure out creative and innovative ways to reuse the materials that we've already put into our lives. So here we have a graph that's showing waste production in millions of tons from the year 1960 through 2010. And we see the amount of paper, glass, metals, plastic, food, yard, and all other have steadily increased throughout the years here. And so all of this ends up in a mix in our municipal solid waste, and there's ongoing efforts to figure out how we can generate new sorting techniques to pull out the things of value. The good news is that as the available landfills decline, we are recycling and incinerating more municipal waste. So we can see here in this graph from 1960 through the year 2010, the amount of millions of tons that ends up in these different disposal categories. We have increased the amount of material that is recovered for recycling, the amount of material recovered for composting, and the amount of material recovered for energy generation. Reducing waste is often the cheapest option. We need to slow the consumption of our day-to-day lives, especially in terms of these disposable products that we use once and we just toss away. You all have probably heard about the 3 R's: reduce, reuse, and recycle. The most important strategy is to just reduce our consumption. We can save materials, money, and energy by just consuming less. Soft drink makers use less aluminum per can than they did 20 years ago. And plastic bottles today, they actually use less plastic. 3M, the company that makes those command strips, they've saved over $500 million in the past 30 years by reducing its use of raw materials, reusing waste products, and thereby increasing their efficiency. So this is all about rethinking our consumption habits. We can do this on any scale. We can do this on the individual scale. We can do this on the household scale, the university scale, the industry scale. All of it can be done and approached in a sustainable manner. So what can you do to reduce your waste? There are a couple of things here. Number one, buy foods that just come with less packaging. Take your own bags to the grocery store, shop at a farmer's market or a co-op, bring your own containers. If you can buy from those bulk containers, bring your own mason jars. Take your own washable, refillable beverage containers wherever you go. Use your refillable coffee mug, use your refillable water bottle. When you have a choice at the grocery store among plastic, glass, or metal containers for the same food item, buy the reusable or easier to recycle metal or glass if your site in your city is collecting glass still. When you're home, separate your cans, bottles, papers, and plastic for recycling, and then make sure to wash those recyclable materials. Composting is gaining in popularity, so if you have the space and time and interest, consider starting a compost bin in your yard. And then also help your schools develop responsible systems for disposing of electronics and other waste. If there's a need, if there's a gap that you identify, talk to your student representatives. And don't just stop there. You could also write to your senators and your state representatives to urge them to vote for container deposits, recycling, and safe incinerators or landfills in your community. So all of that has to do with domestic and industrial waste. Well, let's also talk about hazardous and toxic waste. Hazardous and toxic waste consists of a vast array of explosive, flammable, caustic, acidic, and highly toxic chemical substances that's used in industry, agriculture, or domestic purposes. In the United States, industries generate about 90 million metric tons of hazardous waste each and every year. That's about 3 metric tons of hazardous waste per person per year. About 40 million metric tons of toxic and hazardous waste are released into our air, our water, and the land in the United States each and every year. This is a whole lot, and so there's a lot to unpack here. So the first thing is, where does that toxic waste come from? We have the different sectors here of the generators of toxic waste. We know that metal processing and mining contributes about 22% of our toxic waste. Other industries is about 7%, but by and large, our toxic waste come from chemical and petroleum industry. So generating our plastics, our oil, our non-renewable resources. So what is a hazardous waste? We know how much is produced, we know who's producing it, but really what is it? There's a legal definition of hazardous waste, and that is any discarded material, solid or liquid, that contains substances that are known to be, number one, fatal to humans or laboratory animals in low doses. Number two, it could be toxic, carcinogenic, mutagenic, or teratogenic to humans or other life forms. It could be ingestible with a flash point of less than 60 degrees. It could be corrosive. And then finally, it could be explosive or highly reactive. Highly reactive being defined as undergoing a violent chemical reaction either by itself or when mixed with other materials. So what are the federal regulations that hazardous waste have to abide by? In the United States, there are 2 important federal laws that regulate our hazardous waste management and disposal practices. Number one, we have the Resource Conservation and Recovery Act, otherwise known as RCRA, of 1976. We also have the Comprehensive Environmental Response, Compensation, and Liability Act, or the Superfund Act, that was passed in 1980 and then later amended in 1984 by the Superfund Amendments and Reauthorization Act. And this act is aimed at rapid containment, cleanup, and remediation of abandoned toxic waste sites. You all may have heard of these Superfund sites before. So they're called Superfund sites because those are listed for federal cleanup. And they have a whole bunch of federal funding in a resolving pool that's designed to, number one, provide an immediate response to emergency situations that pose imminent hazards to the community, both in terms of wildlife and humans. And then number two, to clean up or remediate abandoned or inactive sites. So in the United States, there are about 400,000 Superfund sites. And this is the number given by the General Accounting Office. But originally, there were about 1,600 sites that were placed on the national priority list for cleanup with financing from the federal Superfund program. The total cost for this hazardous waste cleanup in the US is estimated to be between 370 billion and 1.7 trillion, depending upon how clean sites must be and what methods are used. So for years, this pot of money, this Superfund pot of money, was mostly spent on consultants and lawyers. And cleanup efforts were often bogged down in disputes over liability and best cleanup methods. But during the years of the early 1990s, progress improved substantially with a combination of rule adjustments, as well as administrative commitment to cleanup. And so by the year 2004, more than half of the original Superfund sites that were listed as Superfund sites have been completely cleaned up or drastically reduced in the amount of contaminants that they have. So some hazardous waste dumps are near aquifers. And as you remember, aquifers are those underground sources of water that's relied on as our groundwater sources. So having these hazardous waste sites located near aquifer recharge zones makes the tendency of groundwater contamination to be extremely high. And so here we have a dot for each hazardous waste site located in the United States. You'll notice that they are concentrated in some areas like California, also in Washington state here. We also have a whole bunch in Michigan and in the Northeast and in Florida. We only have a few here in Tennessee, mostly relegated to the middle and western portions of the state here. So again, the best approach for mitigation of these hazardous waste and Superfund sites is just to produce less waste. This goes with, as with other waste, the safest and least expensive way to avoid hazardous waste problems is just to not create the waste in the first place. We can attempt this by changing our manufacturing processes and modifying them to reduce or eliminate the production of waste just as a whole. And it's frequently found that these new processes not only spare the environment, but they also save money because they're more efficient and they use fewer materials. So for example, in Minnesota, that 3M company reformulated their products and completely redesigned and reimagined their manufacturing process. They did this with an eye toward eliminating that hazardous waste. So as a result of their mitigation practices and redesigning their entire manufacturing process, they have eliminated more than 140,000 metric tons of solid and hazardous waste. They've also eliminated about 1 billion gallons of wastewater and 80,000 metric tons of air pollution each year. So again, with an eye toward conservation, this company, 3M, saved themselves money as well. There are several processes that allow us to convert that hazardous waste into less hazardous forms of that substance. So first up, we have physical treatments. These physical treatments tie up or isolate substances all by themselves, so they can't react with other things. Examples include charcoal or resin filters that absorb toxins. There's also precipitation and immobilization in ceramics, glass, or cements. All of these act to isolate toxins from the environment so that they become essentially non-hazardous. We also have incineration available, and this is applicable to mixtures of waste. A permanent solution to many problems. It is quick, and relatively easy, but it is not necessarily cheap. It's not necessarily clean unless it's done consistently and correctly. So in this incineration process, the wastes have to be heated to over 1,000 degrees centigrade or 2,000 degrees Fahrenheit for a sufficient period of time to complete the destruction process. The ash that results from incineration is reduced in volume up to 90%, and it's often safer to store in a landfill or other disposal site than the original waste themselves. So even though the incineration process is producing ash waste, the ash is safer and easier to store than the hazardous material itself. And then finally, we have chemical processing. In this chemical processing, the materials are transformed to make them non-toxic. Included in this category is neutralization, removal of metals or halogens, as well as oxidation. So this waste often needs to be stored permanently, especially if we're considering that ash waste that's produced from the incineration process. Inevitably, there are some materials that will just have to be stored and kept out of harm's way. There's something called permanent retrievable storage. And this involves placing waste storage containers in a secure place, like a salt mine or a bedrock cavern, where they can be inspected periodically and retrieved if necessary. This approach of permanent retrievable storage is pretty expensive because it requires continuous monitoring, but it has the advantage that we don't completely lose control of those highly toxic substances that could potentially leak into groundwater if they were just buried. Again, we have these secure landfills. They are the most popular solution for hazardous waste disposal. Although many landfills have been environmental disasters, there's newer technology that makes it possible to create safe and secure modern landfills that can contain many hazardous wastes. So as with modern solid waste landfills, the first line of defense in a secure landfill is a thick bottom cushion of compacted clay that surrounds the pit like a bathtub, preventing leaking. And here's a schematic of what that secure landfill for toxic waste look like. As you can see, there are multiple layers of different geologic materials, including the existing clay, gravel beds, sand beds, and then thick compacted clay, which acts as an impenetrable barrier. You'll notice we also have testing wells to make sure that none of that toxic material is leaking into the water here. And we also have tools to remove methane. So to conclude, modern society produces a prodigious amount of waste. Unfortunately, historically, there have been governmental policies and economies of scale that make it cheaper and more convenient to extract virgin raw materials rather than reusing and recycling items. However, in recent decades, the rising cost and declining availability of landfills have led to new and creative strategies to help us reduce, reuse, and recycle waste, both at a large scale and at the individual level. So we have to pay close attention to recycling, reusing, and reducing household and hazardous waste in order to greatly improve our awareness of our environmental liabilities.